So in this class, we will discuss some examination question paper problems in general. The first problem is, it is from the question paper VTU question paper, December 2018. The question is like this: a mass of 580 kg, a mass of 580 kg resting on a rough inclined plane, resting on a rough inclined plane is acted upon by a 6000 Newton force, is acted upon by the 6000 Newton force as shown in the figure. So figure is given here as shown in the figure. If the coefficient of friction is 0.25, that means mu value, if mu is equal to 0.25 at the contact surface, check whether the body slides up or down. Check whether the body slides up or down. So this is the question. So the figure given is like this. This is the inclined plane, rough inclined plane, which is making an angle of 30 degrees with the horizontal. A body of mass m is resting like this on the inclined plane. A horizontal force of 6000 Newton is acted on this block like this. Now we have to check the value of mu is 0.25 for this rough inclined plane. It's a rough inclined plane, therefore frictional force also we have to consider. So the question here is, we have to check whether this body moves up the plane or down the plane. So this is an analysis type of problem wherein all the data are given. We have to check the stability of the body now. So here he has given mass of the block as 580 kgs. You can find out the weight. Weight is given by m into g. 580 into 9.81. It will be in newtons. So the value will be, weight of the block will be 580 into 9.81 in newtons, which is 5689.8, or you can take it as roughly 5690 Newton. So 5690 Newton is the weight of the block. Now let me assume that since the force is acting like this, let me assume that the block tends to move upwards. Let us assume like that. Let us assume that the block tends to move up the plane because the force is given like this. Let us assume that we don't know whether it is moving up the plane or down the plane. If we assume like this, then this free body diagram of the block, if you write, so this is the block whose weight is W. W is how much? 5690 Newton. That is the weight of the block. Now since I am taking that, I am assuming that the motion is up the plane like this due to this 6000 Newton force. So this block is making an angle of 30 degrees with the horizontal like this. Since the motion is like that, we have assumed like that, the frictional force at the contact surface will act in the opposite direction. So this is like this. F is the frictional force which acts down the plane, and normal reaction will be like this. And we know that F is mu times N, limiting friction reaction is equal to coefficient of friction multiplied by the normal reaction. Coefficient of friction is given as 0.25 for the plane. So it is 0.25 times n. That relation we can write down. Now we have to check whether the block moves up the plane or down the plane. So we have assumed that the block moves up the plane. Suppose if the friction force, after assuming this, suppose if the friction force value are going to get negative, then it will act like this in the opposite direction and the motion will be downwards. If you get the value of friction force positive, then you can say that assume direction of friction is correct and the block moves upwards. So that is how we have to decide. Now let us check the equilibrium of this block now. So since I have taken like this, I will direction of motion itself is taken as x-axis, perpendicular to that it is y-axis. Now we have to apply the equations of equilibrium along both x and y directions. The first equation of equilibrium is sigma fx is equal to 0. Since I have taken up the plane as the positive x direction, so forces in that direction I will take positive, other opposite direction I will take it as negative. So in order to have that, I have to resolve this 600 Newton force also. So like this. So this is the resolution. Since this is 60 degrees, this is 30 degrees, this is 30 degrees. So you can say that this is also 30 degrees. Since this is 30, this becomes 60, this becomes 30. So this is how we have to take the angles. So see, this is 30, therefore this becomes 30, this is 90, therefore this becomes 60, this becomes 30. That means this force will be 6000 cos 30 and this will be 6000 sin 30. So that is the resolution, because we have to resolve the 6000 Newton force along the x and y directions. The component in x direction is 6000 cos 30, component in y direction is minus 6000 sin 30. So those two things are important. Now I will write sigma fx is equal to 0 for this. If I write that, so this is positive, so 6000 cos 30 is positive because it is acting in the positive direction of x axis. Then we have to resolve this W also. If we resolve the W, so it will be like this. So it is like this. Parallel to the plane, perpendicular to the plane. So it will be like this. Now here also this becomes 30, this becomes 60. So you should be careful about the angles. This becomes 60, therefore this becomes W cos 60, whereas this becomes W sin 60. Now the component of W in x direction will be minus because it is like this. So minus W is here 5690 Newton into cos 60. It is negative because it is acting in the opposite direction. So I have taken this force, I have taken this force. Then F also I have to consider. F is negative. So minus F is equal to 0. So this is the equation we got. So this F is negative. Then you got this 6000 cos 30 positive, W cos 60 negative. Okay. So now if you simplify this, you will be getting 6000 into cos 30 minus 5690 into cos 60. So it comes out to be 2351.15. 2351.15 minus F is equal to 0, or F is equal to 2351.15 newtons. This is the friction force we get. Now, normal reaction, that means the second equation. sigma Fy is equal to 0. If I do that, then what according to sign convention, forces in this direction is positive, the opposite direction becomes negative. Now seeing to that y direction forces, this is negative, this is also negative, only n is positive. So n is positive, minus w sin 60, that is 5690 sin 60, and this is also negative, minus 6000 sin 30 is equal to 0. So therefore n will be equal to, so both becomes positive now, 5690 into sin 60 plus 6000 into sin 30, which comes out to be 7927.68. 7927.68 newtons. So this is the normal reaction. Okay, that means both F and N got positive values. So both F and N we got the positive values. Now we have to check whether this F is equal to mu times N, whether that condition is satisfied or not. So from this whatever value obtained, mu is equal to F by N. If you take that, F is 2351.15 divided by N is 7927.68. The ratio, if you take that, 2351.15 divided by 7927.68, you are getting 0.297. That means here the value of mu given is 0.25, but obtained is 0.297. The meaning of that is this F value obtained from the analysis, whatever you have, it is slightly more. That means suppose if you take, if you calculate the F value by taking mu given into N, so it is 0.25 into 7927.68. So that means it will be 0.25 into 7927.68, 1981.92 newtons. So this is from the given. Actually, this is the limiting value. So this is the limiting value, maximum value of friction. So what you can get that maximum F value. But here the F value obtained from the analysis is greater than this. Assuming that the block tends to move up the plane, we got F value as 2351.15 Newton. Actually, this value is greater than F min or F maximum value. Therefore, the assumption is wrong. That means, assuming that the block tends to move up the plane is wrong, because the maximum value of friction that can develop is only 1081. Assuming that it moves up the plane, we got the value 2351.15, which is greater than the maximum value. Therefore, the assumption that it moves up the plane is wrong. So we can say that hence the block tends to move down the plane. This is how we have to check. So we have to calculate the F limiting value by mu into n, by taking mu into n, and assuming initially we will not be knowing in what direction the block tends to move. We can assume in one of the directions and then check whether the maximum value of F we got from the analysis it is less than the limiting value or not. So F value we have to find out assuming certain direction of motion of the block. Then compare that F value with the maximum value of F or the limiting value of F, because mu is given in the problem. So therefore, once you can compare, if the value of F obtained is less than F limiting, then your assumed direction of motion is correct. Otherwise, it is in the opposite direction. So this is how we have to decide about the direction of motion of the block. So this is a different type of problem. So a type of analysis type of problem. Already all these forces are known. Only thing is we have to check whether it moves up the plane or down the plane. He has not given the direction of motion of the block. You have to decide the direction of motion of the block for the given force system.